Hello again. This is kind of version 2 of the filter circuit with the inrush protection. So it's got a bit more complicated. I'm not even sure whether I'm solving a problem that will exist, because I think capacitors can handle short bursts of about 100 times more ripple than normal. But it's possible that doing what I'm trying to do here might extend the life of the capacitors. But I guess the main reason to do it, well, I've got to put capacitors in there to stop the ripple and make the other voltage regulator work properly, because there was too much ripple before. So that's solved by this 5 and this one. But this circuit, it works by the same time constant. So a time interval after the power supply starts up. So this will start charging, but when it's in the time before it charges, this will be low. Therefore, the current into the capacitor is limited by 1.5 ohm resistor. After that time delay, this goes high and then switches in the relay, which shorts the resistor, which means that it's essentially full power. But now when the power supply turns off, you want it to immediately open this relay and restart that time interval when the power is applied. But the problem with that is that you can't drive that circuit from these, because they'll still be charged. So this other relay, so there's this relay which is normally open and closes when the thing starts up fully, but this one's normally closed. I can't get the diagram. So when the power supply turns off, this will close and short out this capacitor, causing the time delay to restart, and the coil resistance of the relay will quickly discharge these much smaller capacitors. So what I'm expecting to see is there's a turn on, and these capacitors charge up until the time delay, then they charge up faster, but there's never too much inrush current. And when you turn it off, the time delay, this capacitor immediately gets shorted out, so that if you quickly turn it back on, the power supply turn back on, then this will all be discharged. This might not be, but this will be, and the time delay will restart. So if I simulate it, which I have, so I'm going to start from scratch. Actually, it's easier to visualize. So that's the so if we look at the voltage, so I've got some delays in these. So there's two signs which just mimics switching on, then off, then on again, and I don't know how to make some kind of, because these are separate, is that the relays essentially isolate both circuits, although the simulator, I don't know whether understands the concept of two separate circuits, or I don't understand how to do it. So it looks like my delay at the moment is half a second, and then and the whole point is the inrush current. So we're getting a maximum about 4.5 amps. when it turns off, when I switch the switch off, so the main power supply dies slowly, but the 5 volts dies much more quickly, which means this signal is off much more quickly, and then when you switch it on after whatever number of seconds, it's going to be connecting. This is open, and this, so the main capacitor is charging through the 1.5 ohm resistor. So the inrush is limited. And I've tried various combinations, various time delays. So if what I want to do, 3.8. So I go, what's the worst case? So I want 3.2. What happens? This one, 3.2. So yeah, I'll have to do it manually. I think you should be able to have variables in it. Just want to get the inrush. It's still about a little bit less than 4.5 amps. This is the one that matters, the steady state. It's a bit lower. That's good. So the main thing is starting the power supply is a half a second delay before the capacitor. So there's a half a second delay while the capacitors are charging through the 1.5 ohm resistor, and it happens again here because this relay's just discharged this circuit, discharged all of this, so that the timer will restart. Let's just change this to 9 and see what happens. The inrush should go up, I think. Whoa, that's high. So I may not have solved the problem perfectly. Why? That's amazing. That's a big spike. So if I go back to 3.8, what does it do? I need to find out how to use variables in this thing. Ooh, okay. Something pathological happened before. I don't know what that meant. So is it 3.1? Not 3.2. So I would have thought that the closer you bring the quicker you do it, the less the main capacitors will have discharged. Although, yeah, it's interesting. Where's the voltage here? Let's see. No. What? Okay. I don't understand what happens. So there might still be a bit of work to do. I don't know. I need to think about it a bit more. It's a bit low. Ah, that's right. So when it's drawing a maximum of 2.2 amps. I mean, they probably will be okay. I don't like that. 0.5, 3.5. Something strange happens when they're together. Could be it might be a simulation issue, I'm not sure. There's something going strange here. So if I put it 3.2, no, oh, maybe I didn't change. What did I? Oh, that's already the one I did. Oh man. Yeah, something strange. So if I look at the that doesn't make any sense to me, because the capacitive, it's still within the, it's charging up to the same point before. It might just be the resolution, 3.21. Yeah, it may be just that it's just some multiple of the input frequency. So if you get it right, you can get 12 amp spike. Interesting. Anyway, I don't know whether anyone's going to be interested in this, but this is kind of my thought processes. It's possible I should lay this board out and build it and see what happens, but I would like to know that I'm doing the right thing with these capacitors. Because once I finish building this, I don't really want to have to, I don't expect the things that I make to fail. So I want to make sure this is correct. Sort of check something. What's the maximum? 50 milliamps, that's good. I think that's the relay coil, which I think it might be 500 ohms actually. What are the, I did notice before this, that's the secondary winding of the transformer. That couldn't, they're spikes, because they're only, the transformer's only rated to 2.5 amps, but that might be RMS. That doesn't seem right to me. The diode bridges that I'm using, in no way then, I think they're 25 amp bridges. I'm not sure if the simulation's accurate at this point. Well, this is peak and not RMS. Possibly. Not sure. Anyway, I'll publish this even though it's me rambling on a bit. Thanks for watching.